for pipe. The general, the pipe, ordinary pipe is any process put the message and the receiver, any process can take the message. So, what if I want to specify the pipe, so not general pipe, so I'd like to use this pipe for my family only. At the time you can name, specify the pipe that is called named pipe. So you can use it for specific purpose. So it can be accessed without parent-child relationship. Instead, it can be used for specific purpose. So this is from this one. So parent size is this is a sender and this is a receiver. So in case if you want to communicate each other, so each process should be, in this case, the input and the children process get the output. Also, this one can put the input and parents will get the output of the pipe. Okay. So it's based on actually the producer-consumer problem. So we have seen different producer and consumer problem for the communication. So pipe follows such a producer and consumer the problem. So parents is a producer and the child processor is the consumer. So consumer read, the child processor read such a data. Windows use anonymous pipe. Okay, so that only ordinary pipe is the same thing. For the named pipe is more specific purpose, so it's more powerful. Also, communication is bidirectional, which means in this case it's one directional. It's a first in, first out. That is the reason even parents should the child process need to put the message from this right end and get the data the read end, like this way. But in named pipe is bidirectional. You can specify the pipe for the communication, and there are two processes they can communicate each other. At that time, there is no parent and the child relationship. It's used a lot. Also, not just for two processes, but you can use several processes for the communication in this pipe. So it's kind of a medium for communication. Okay, that is the end of chapter 3. Any question regarding to the process management? I don't understand why it's so slow after Office version is changed. It's very slow. Do I need to save as the new one? Is there any function? Save as. What's the version of this? Is it Windows 8?
Yes.
Not touch screen. Okay, next topic is a part of process management, but it's called the thread. I think I mentioned the 1 or 2 times of what is a thread very briefly during the process management. So thread, first, what is a thread, by the way, before we start? Thread is what is a program? Program is an executable file that includes your source code? No, it's a instruction machine language. From your source code, it's a source file. You cannot execute the source file until it's compiled. Compilation means
validation.
So convert such a high level, the human language, almost like the C language, dot language, any language is close to the human being. Okay, you can understand, but computer can understand, so we need to convert into the only one language that computer can understand, that is a machine language, assembly language. So convert into the assembly language. So each unit is called instruction. It has list of the instruction. So why don't you use ultra edit editor or something? So there are some debugger program, okay, that you can browse the instruction of your program. Then it has almost, there might be someone who can understand such a machine language code, okay. I heard that somebody can directly debug the machine language assembly code, but I even never tried, except the microprocessor class a long time before. So this looks like the thread. Okay, so this is called the thread. So if your program executable file is very simple, like to read the data and display, that's it. If that is your instruction, the data thread of your instruction is straight line, like the straight line. You need only one thread of the instruction, start to end. Okay, so very simple. However, think about your web browser. So web browser, like the Internet Explorer or Chrome is. So already we have discussed about the structure, architecture of the Chrome. Chrome has at least 3 groups of processes, right? It has the communication, browsing, and the plugin, something like that. Even for the browsing, when you browse your Internet Explorer, browse the HTML file. If HTML file has only the text data, which means HTML file, it's okay. However, sometimes it has embedded browser or embedded images, and this one is a video. So you request HTML file, text file. Then next this one. This is one thread of the file. What if we request this one separately? One of the solution is we can create child process. The problem is it takes a time. Also, if something problem, it will be crashed. So, well, anyway, the process of the browser has all the code, programming code in your process structure. What we need to do is connect this part and get the data stream. So, can we separate the job within a same process? Okay, we need to share the same global variable and the local variable, some temporary data, but the only difference is that this one get the text data, this one get the image data, this one get the video data. Okay, so at that time we can, instead of creating new processes, we can share the almost the common part of the process structure instead, except the specific thread of the instruction program. So in this part, we can say this part is for imaging, this part is for video, this part is the text. So we can learn this part separately, but the other we are going to share. So this is called thread architecture. So nowadays, almost all the modern operating systems support such a thread programming. Even kernel is also process. Okay, there are a lot of jobs that should be done in the kernel. So only one thread of the process, it will be very slow. Every operating system job, like the algorithm, scheduling algorithm, disk I/O, the controller, everything should wait until the thread is completed. Instead, why don't we create such a thread to speed up? Yes.
All that you mentioned, they will share the same thread about the images and the videos
we are going to share for example, this is the Internet Explorer program. Okay, it's a one set of instructions. So we wrote this one into the process structure text area. Okay, we don't have to create a new process for this. This is not a separate process. Okay,
Well, what's the difference in this case? What's the difference?
so we will see
Until
the difference. We will see which one will be shared, which one is not. Idea is instead of creating a new process, we are going to share more, as many common area possible, then allocate the different series of instructions for specific purpose. So we will see what kind of data will be shared, what kind of data will not be shared. So idea is we want to maximize, because we have the limited computer, especially CPU resources. Anyway, we need to share such a thing. But we'd rather speed up such a processing the data. But creating process, as you have seen the previous chapter, creating process is very expensive. It requires context switch. Context switch include writing a data, the reading a data, and you need to save some. It takes up time. So instead of the creating new process, we can minimize such a creating process by allocating a thread of the process. Okay. Somebody said this is kind of a parallel approaching, but a little bit different. So we will see. It's kind of parallel thread. So we will see the details of it. Okay. So nowadays, most of the computer system, especially operating system, support such a multi-thread. Multi-thread programming. Yes. Idea is thread looks like the process, but it's not process. It's inside the process application. Within application, we can create different. It's a part of the series of the instruction. But only for this part, we create the kind of small program. Okay, within one process, we will create it. That is called the thread. For example, we can, using such a thread, we can do the multitasking. Like the one thread is in charge of the update display, another one is getting the data, and another one is a spell check while you receive the data, and third one, answer network request, something like that. It can increase the efficiency. Okay, definitely. Main purpose of the creating thread or the using the thread is efficiency. How to speed up the process. So kernel, for example, kernel is a good example of such a multi-threading. If kernel is the single thread process, all the operating system, the functionality, they should wait until the current one is completed. Okay. So what is a thread? It's kind of independent series of instruction, as I said. So this part. So if they are correlated, you cannot use them. You need to communicate thread by thread at that time. Like the process by process, inter-process communication, you need the thread. For example, Java actually allows such a thread communication. So when you create the Java process, it will be running on top of virtual machine. In the virtual machine, so you create a thread object and you can make the runnable as many as possible until your Java virtual machine allows the resource. Then between the thread you can communicate by allocating the global variable or by allocating the other object for communication. So yes, you can do that easily in the Java. So that is the reason, actually, when you are using the Java, you may not realize whether you create the thread. Actually, Java use a lot of such a thread whenever you create a new project object. Okay. For here, in general, the thread programming, so this each series of instructions should be independent. So it looks like the parallel running. However, it is true. So you have only one CPU time. You need to share the time. Okay, we will see multi-core programming the later. So in the multi-core programming, anyway, you cannot increase the hardware, the power. Okay, within a given hardware power, you'd like to maximize such a performance efficiency. Okay, so what kind of the information cannot be shared in the thread? For example, stack pointer. So stack row is a, what is the stack? What kind of information are stored in the stack area?
Variable.
Local variable. Okay. If that function, that object is the completed, you don't need object collector, cleaner, such a thing. So local variable, for example, if a thread has a local variable, so each thread should have their stack area. Okay. Then the register definitely. So this one has their own register information, register 1 to read the data, whatever. So it cannot be shared. And scheduling property, because thread can be considered as one the PCB information, which means it will be regarded as one process for the scheduler. So scheduler need to assign one of the thread to get the CPU resources. So scheduling property cannot be shared. It's independent information. Okay, some block or the pending signal. Okay, and the thread specific data. Other than this one, it can be shared. So we can maximize. So this is, for example, here, this is the process structure. So in the PCB. So in the PCB, there are pointer. Is a location or address of the instruction of the process. And process state, we learned about the 5 different state and process number. And also memory limit. All of this can be shared by the all thread, except that this part, the thread specific information, like the program counter, register, this kind of information. So instead of, if you want to create a new processor for the specific job, you need to allocate all this information. So you can reduce the time. So for example, program counter, for each thread, this thread has the program counter 3000. So 3000 address of the 3000 will be executed from this thread. And this one is 300,000, the program counter. This one is 4,000. You can simultaneously, same time, run 3 threads within one process. So this is the example of the when you can use the thread. Okay. So suppose that you have the 2 processes or the 2 core within one CPU chip. So let's say that is a CPU 1 and CPU 2. So if you allocate the 2 threads, one is for printing job and another one is the read the data from the network. Okay, they can be done simultaneously because they are independent job. So at the time you can create the 2 threads for different job. So this slide shows a high-level overview of the single thread and multi-thread. So as you can see, so each thread has their own stack and register information, but they share the code, the instruction code, and the data and files that this process is open or handled or locked, such a file information. So this is the multi-thread processes. Yes.
The memory. You will share it also.
This is the memory structure. What is the process? Process is this one where it's in the memory. Okay? Process, whenever we are saying the process, that means it's a memory where the program are loaded But how can we allocate, how can we use the memory? In this case, we use the process memory structure, only one thread of instruction. But here, for the same size of the memory, we use 3 threads. So it's kind of the parallel processing within one process. As many as possible? No, actually, not. When you have the single core, which means we have only one CPU, one core, which means at certain time, only one instruction can be processed. One set of instruction actually can be processed. Okay? Then, this time normally 2 to 4 thread or processes can be processed same time. It depends on the CPU chip, but roughly 2 to 4 process can be parallel. Which means even though you create 8 threads in this CPU, one core CPU or one CPU or one core CPU, you cannot get the full benefit of this one, even downgrade performance because of the complexity. So you need to consider such a number of processes. However, when you have the 2 CPU or the multi-core, dual core, you can increase that one. But as many as possible, there might be a limitation. We will see Amdahl through later. So POSIX thread, P thread, this is called the P thread. P thread, such a POSIX thread, something thread, is not the implementation. It's kind of standard. To implement a thread, there are different ways of the implementation. So POSIX thread, the specified. When you create the thread, you can follow such a way. So it's commonly used the Unix and the Linux system, POSIX thread. Okay, so at the time, so thread one has their own stack area and pointer area, counter and register. That will be managed in the text area of their process. And this one is a single process, the thread process. And what about the thread 2? Thread 2 will be stored at the stack area. Stack area is a thread 2 stack, and their local variable, also their information in many times the text area. This is the global variable. So what is the benefit? So these are the list of the benefit of using thread. The first one is the response. Responsiveness. So multi-thread. So even one thread is done, the block or the crash, you have the other thread. So your process is running, still running. And also, definitely it's a shared resource, limited resource, so it's maximize the resource usage. Somebody text whether creating process, which one is best? So creating process versus creating thread, which one is the best? So they realized 30 times. This one is 30 times faster than this one. Okay?
But if the crash happened, something crashed happened,
This is a performance test, just a benchmarking test. So they just measure to create, for example, 10,000 of children process. This one, 10,000 thread in one program. Then they just measure how long it takes. CPU time measure. So this is not the real implementation of the application. This is a performance test, benchmarking test, to show whether thread is faster than the creating process when we create the thread data structure. Okay. Also, we can utilize using thread when we have the multi-core or multi-processor architecture. we can get the benefit of that by assigning, like when we have the dual core, we have the two thread, assign the thread from the schedule. Right? Maybe easier. What if when you have the single core, still you need to schedule by thread and thread by thread. When you have the multi-core, multi-processor architecture, it will be much easier. So you can get the benefit of such utilization of MPA architecture. Can be parallel. So this slide shows the performance between fork and the pit thread creating. So along the different the computer chips, roughly the 30 times. This is a CPU time. Where user sys. Where is real CPU time? Then what is the user CPU time? What is the system CPU time? When you measure or monitor, manage the CPU in the Linux system or Windows system, you can see three different CPU time. One is real. Real is the total CPU time. What about the user CPU time? And what about the system CPU time? Can you remember the dual mode of the operating system? There is when you create the process, then run your application at the time, there are two modes. So first, user mode. So user mode call the system call who actually execute such a system call library. Not user. User just pass the parameter value. Then kernel will take the job and process it, read the data, and return the value to the user. So kernel mode and user mode. So user means such a how during the user mode, how long the CPU times are used. And similarly, system kernel mode. It should be balanced. Roughly 1 to 3. Why? If user mode is very busy, which means you have too many operations, CPU using computation. Okay? So kernel cannot get the CPU resource. Okay? If kernel cannot get the CPU resource, all system call will be delayed. Like when you read the data, when you create the file, when you create the process, it takes a time. So it will be slow. So it is recommended to have 1 to 3, the ratio. So which means 25%, 75%. It's not exactly 1 to 3, but roughly based on experience. So for such a user, the dual mode, so user mode and the kernel mode. So we already discussed about the kernel thread. So there's a kernel, there's a user. So user mode and kernel mode, you can communicate each other. You can request the system call, then kernel mode will execute it. So what if we have the thread of the kernel? It's a kernel thread. It's most popular. What about the user? User may be busy also. So user program can be the thread. So that is the user thread. So such a thread can be managed by the user level, user mode, during the user mode. But if the kernel block or the kernel is taking the job of the user request, no matter how many you how many user thread you have, it will be entire process will be blocked. Why? The kernel will take over the job. Such a user thread usually independent from the operating system. Operating system is managing kernel thread, kernel node. There are different types of the user thread. So POSIX that we have CP thread, and the Windows 32 has the thread, and also Java thread is very popular on top of the Java virtual machine. So you can create your thread and you can change the state of it. We will see the example of that. Similarly, we can definitely have the kernel thread in the kernel level. The operating system is in charge of the such a managing kernel thread. Even though one of the kernel thread is blocked or the stopped, the other kernel thread is still running for other users. So it has the user thread and kernel thread. It has the same the benefit. Also, there are a couple of others. Economy is cheaper because it's expensive and cheaper means it uses less the computer resource during the context switching. We don't need the context switching. We need the context switching, but thread switching is much simpler than context switching. Also, it's a parallel processing, which means it has the scalability, so we can increase. Linearly, not forever. We will see the Anders rule. There might be limitation, like the low graph. Then so one of the benefits of using such a thread is we can do the parallel programming, so which means multi-core program. Is there anyone who took the parallel programming class? Yes. So at the time you design such a task or block. So sometimes the designing level you need to change existing code. Sometimes, depending on the algorithm, some of the operating system or the library manage such allocating from the existing source code, existing the program. You can the operating system level make the different thread allocate the job to the core, but not always working. So your application should be changing. So we are not going to cover the multi-core programming itself, but we will see the benefit of such a multi-core programming. So there are different. Actually, the multi-core or the multi-processor programming is not easy. Definitely, the different from the single core or the traditional programming, because we need to consider first dividing activity. So if our program is clearly divided into several groups, they are not correlated a lot. One is totally independent, then we can assign this task activity to the one core, this one is another core. So it will be possible, but not always. Sometimes you need to communicate each other. So that's the difficulty. Another issue is you need to consider balance. For example, this job is used 10% of the CPU resource. Another job is